Actually, I'm logging to my console. Okay. So I'm taking a region as North Virginia. It's a default. Okay. I'm going to EC2 instance. Launch EC2 instance. Here something like a k8s master. So browse Ubuntu. Guys. So this is Ubuntu server 20.04 LTS. This is the SDT type. So and Ubuntu server 22.24 LTS. This is, guys are able to see these two are the free tier. I selected the 22.04. Right. Then you can select the T3 medium. Because of why we are taking T3 medium, T2 instead of T2 micro. So we need a 4 GB of RAM. We need a 4 GB of RAM for installing the Kubernetes on the master node. So that's the reason we are taking the T3 T2 medium. Okay. So T2 medium, select the key pair, and I ask you to guys create a security group, guys. I created a security group for Kubernetes SG. So then launch instance. Then launch instance. So what is the problem here we are facing? Is it easy, right, guys? So is it easy or not?
బ్రో అక్కడ ఉబంటు అనేది నిన్న చాలా సార్లు
Yeah, browse more AMIs and select the
చూసాం బ్రో.
Ubuntu sir. I can share your screen if you are in laptop.
మొబైల్ నుంచి జాయిన్ అయ్యాను నేను.
సో ఎందుకు మొబైల్ నుంచి జాయిన్ అవుతున్నారు?
నా ఫ్రెండ్ వాడుకున్నాడు, ఏదో వర్క్ ఉందని ప్రస్తుతానికి.
Okay, guys, as your wish. Yeah. Let's continue. So this is the recording, right, guys? This is the recording I already uploaded. You guys just go through it, right? This is the cluster setup, right? So this is the record. You guys can go through it, right? Okay. What we discussed yesterday, we discussed about the how to install the Kubernetes cluster, right, guys? And you know the a master node and worker node. What are the components in the master node and what are the components in the worker node? Guys, tell me what are the components in the worker node? What are the components are there in the worker nodes? Guys, tell me. Guys. Guys are able to hear?
కంటైనర్.
Okay. Okay.
డాకర్ క్యూబ్లెట్.
Mm. Mm-hmm. Next. Guys, Rafi, Fanikun, Fanendra Kumar, Lavanya. Yeah. So what are the components in the worker node, guys? What are the components in the master node or a control plane, API server, scheduler, control manager, and etcd. So what are the components in the worker node? A pod, container, Docker runtime, kubelet, and kubeproxy. Okay, guys. Yeah, we done the setup, right? So we done the setup, self-managed Kubernetes cluster. So cluster setup, Kubernetes cluster we can set up in multiple ways. Self-managed Kubernetes cluster and provider managed Kubernetes cluster. So self-managed Kubernetes cluster means so we need to install our own, right? Yeah, guys. The task is the task, guys. So what is Docker Compose? These 2 days you guys can search it anywhere and please let me know the Docker Compose. Okay, what is Docker Compose and how to write the Docker Compose files. Okay, guys, this is the task, guys, and you guys can install. Try to install Minikube also, guys. What is, guys? Try to install the Minikube also. So these are the tasks, guys. So this is the task for you guys these 2 days. Okay. Yeah, guys. So So the mini cube setup and the Kubernetes setup, Kubernetes cluster we can set up in multiple ways. One is self-managed Kubernetes cluster and the managed provider managed Kubernetes cluster. AWS EKS, Azure AKS, AWS EKS, GCP, GKE, IBM IKE. So the self-managed Kubernetes cluster, KubeADM is nothing but a multi-node Kubernetes cluster, and the Minikube is nothing but a single node cluster. In the single node cluster, so master node and the control node and the means master node and the worker node both are in the same 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 EC2 instance. So Kubernetes cluster setup, provider manager cluster means we will use Kubernetes cluster which is configured by someone. So something like EKS, Elastic Kubernetes Service, Azure AKS, Azure Kubernetes Services, GKE, Google Kubernetes Engine, and IKE, IBM Kubernetes Engine, guys. Right? So how you can EKS by EKS? This is the service, guys. This is a service, Amazon Elastic Kubernetes service. In the Amazon Electronic Kubernetes service, you can add the clusters. Add a clusters. So Kubernetes cluster setup, Kubernetes cluster setup. Create a one security group with. We already done this, right, guys? Kubernetes cluster, self-managed. So master and work node, you already knows how to install this master nodes and worker nodes. So this is for installing the kubeadm, kubectl. Okay, Kubernetes, Kubernetes core components, Kubernetes resources, objects, and workloads. So the container is there, pod is there. What is a container? You guys also know container. Pod, you need to know the pod and namespaces, what is service and what is deployment, and a container, pod, namespace, service, deployment, replication controller, replication set, daemon sets, persistent volumes, stateful sets, and roles, and secret config max. Guys, everyone can speak out. So what are the resources, objects, workloads in the Kubernetes concept, guys? Container. Guys, everyone can speak out. Container.
Hello,
POD,
am I audible?
Yes.
namespaces,
Yes.
service deployment,
Yes.
operational set,
replication controller,
replication set,
replication set,
demand set,
hmm, persistent volumes,
stateful sets, full
secret config maps.
config map.
Yeah, so Kubernetes core concept, we are using Docker to create a container for our application. So what is that? So what is guys? We are using a Docker to create a container for our application. So Docker will be used as a runtime engine in the Kubernetes cluster. So Kubernetes is used to manage our Docker containers. Kubernetes is used to manage our Docker containers. So Kubernetes will manage our containers, but no directly. It will use pod to manage the containers. So what is that? Kubernetes is used to manage our Docker containers. So Kubernetes will manage our containers, but no directly. It will use pod to manage the containers. Okay, pod is a smallest building block which we can deploy in Kubernetes cluster. Guys, what is a pod? Pod is a smallest building block which we can deploy in the Kubernetes cluster. So containers will be wrapped under one unit called as a pod. Guys, so container will be wrapped under one unit called as a pod. So one unit called as a pod. So one unit, so called wrapped up into one unit or grouped into one unit is called as a pod. So one unit is called as a pod. Guys, understood? So pod is the smallest building block which we can deploy in Kubernetes cluster. So Kubernetes is used to manage our Docker containers. So what is the Kubernetes, guys? Kubernetes is the orchestration tool. It will manage the containers, right? But Kubernetes will manage our containers, but not directly. It will use pod to manage the containers. So within the pod, we have a containers. A pod is a smaller building block which we can deploy in Kubernetes cluster. Containers will be wrapped under one unit called as a pod. So in Docker, container is the smallest part that we can deploy where as in Kubernetes pod is the smallest part we can deploy. The same guys. Container is the smallest part that we can deploy, whereas in Kubernetes pod is the smallest part we can deploy. So to get clarify in the pods, we need to understand the namespace first in Kubernetes, guys. So first we need to understand the namespaces in the Kubernetes. What is a namespace? What is a namespace? Namespace represent a cluster inside another cluster. A namespace represents a cluster inside another cluster. Kubernetes components will be grouped logically using namespace. Guys, now you can listen. Kubernetes components will be grouped logically using the namespace. So note we can consider namespace as a package in Java. So we can consider namespace as a package in Java. Something like doevo package, service package, util package, control package. Everything will be grouped together. Grouped to so namespace as a package. Kubernetes components will be grouped logically using the namespace. So the components will be grouped logically using the namespace. We can consider namespace as a package in Java, something like these all are there. So we can have multiple namespaces in Kubernetes cluster. We can have multiple namespaces in Kubernetes cluster. So we can get all the namespaces using the below command. So kubectl get namespaces are kubectl get ns. So what are the namespaces? They have a default namespaces, so it will be used by the default. We haven't specified our namespaces. So if you haven't specified any namespaces, so it will be used as a default. So what are the namespaces default? Some of the namespaces. Kube-system. It contains a Kubernetes control plane pod. So kube public. It is reserved for Kubernetes system usage. It is reserved for the Kubernetes system usage. So I will show you that. EC2 instances. Kubernetes master. Yeah. So default it will be so something like kubectl get namespaces or a kubectl get NS. It will be used by the used by default when we do when do want really our namespaces. Something like a cube hyphen system. This is one of the namespace. It contains Kubernetes control plane pod. So kube public. So kube hyphen public. Okay. So it contains Kubernetes control plane and pods. Kube public. It is reserved for Kubernetes system usage. So namespace creation. How you can create the namespace, guys? So how you can create the namespace? It is not recommended to run our pods using the default namespaces. So we have to create our own namespaces to run our pods. So it is not recommended to run our pods using the default namespaces. We have to create our own namespaces to run our pods. Create our own namespaces. How you can create, guys? kubectl create namespaces. kubectl create namespace, something like SBI customer app, SBI agent app, SBI report app. These all are the three namespaces. So in the name, so every namespaces having you can create your own something like the applications. SBI customer is this is related to customer. This is related to the pods. Pods and applications are related to customer. The pods and application related to agent. The pods and containers, the pods and containers will relate to application will related to depot. So these are the microservices. So every microservices you can create our own custom namespace. So we will run our pod using the custom namespaces. So how to get the pods belongs to the namespaces, I will show you guys. Okay. Yeah. Connect guys. So for the Ubuntu OS, what is the default user, guys? Ubuntu is the default user. You see, for EC2 instances, for Amazon Linux, EC2 is the default user. Yeah, guys. So what is the command, guys? So what is the command you need to get? Uh, kubectl get nodes. Kubectl get nodes. So yeah. So what is the how you can see it, guys? So we can get all the namespaces using the below command. What is that command? kubectl get namespaces. What is that command, guys? kubectl get namespaces. Yeah. So default namespaces, uh, kube flannel, kube node release, kube public, kube system. These are the two, right? Kube public and kube system. Default, it will be used by default when we don't specify our namespaces. If you are not specifying any namespaces, it automatically take it from the default namespace. So kube system, it contains Kubernetes control plane pods. It contains Kubernetes control plane pods. Kube public, it is reserved for Kubernetes system usage. It is reserved for custom usage. You see, guys, this is the one namespace and this is the another namespace. System is for contains the control plane pods. All the control plane pods are available in the system kube system. So kube public, it is reserved for the public. It is reserved for the Kubernetes system usage. It is reserved for the custom usage. Got it, guys? Yeah. So what is the command? kubectl get pods hyphen all namespaces. Yesterday we executed this command, right? So what are the namespaces? So system. So what is that, guys? Cube system. Cube system having the code DNS, etcd, kube API server, kube controller, kube proxy, kube settler. So what is that, guys? So cube system contains the Kubernetes. Cube system contains the, yeah guys, cube system. It contains the all the Kubernetes control plane pods. Guys, understood? All control plane parts. So what are the control planes are there? What are the components are there in the control plane, guys? Kube, that control manager, API server, etcd, right, guys? These all are the pods. These pods are running. These pods are a scheduler, controller, API server, etcd. These pods are running in the kube system. It contains Kubernetes control plane nodes. So kube publics, it is reserved for the Kubernetes system usage. Cube public. Now we get, guys. So how you can get the namespaces? You can get the namespaces kubectl get namespaces. How you can get the parts of parts? These are the kubectl get parts hyphen all namespaces. These parts are running. These parts are running while installing the Kubernetes, because so we need to run the Kubernetes, right? For this purpose, we need to run these containers. When these parts, a pod is a smallest building block. It contains the containers. It contains the containers, guys. Understood? Yeah. So create our own namespace. kubectl create a namespace. So namespace name. kubectl create namespace. SBI customer app, SBI customer needs, and SBI customer report. So we will run our pod using the custom namespace. So we will run our pod using the custom namespace. We can create these three namespaces, guys. For example. So what is the example? So we need to create our own own namespaces. So something like how you can get the namespaces. These are the namespaces. So right, how you can create the namespaces? kubectl kubectl create a namespace. Create a namespace. For example, SBI customer app. For example, this is for the customer app. This is one namespace you created. So kubectl create namespace SBI customer app. So namespace is created. Then, so what is that, guys? Agent, SBI agent app. So this is the agent app. Then SBI report. If you want to report anything, right? The suspicious. So this is also one app, one namespace. So now you can get the kubectl get namespaces. Get namespaces. So what are the namespaces? Yeah, so before it is only it's related to Kubernetes, but we created a namespace, three namespaces. So what are those? SBI agent app, SBI customer app, SBI report app here. So we will run our pod using the custom namespace. So we will run our pod using the custom namespace. So right, guys. So So kubectl get pods namespaces. Kubectl get pods hyphen n cube system. Kubectl get namespaces. Kubectl create namespace test app. Kubectl get namespaces. Kubectl get namespaces of test app. Something like what are the pods are there in the, so in the SBI agent we will check it, guys. Kubectl get namespaces. We already know, right? Kubectl get get pods hyphen n SBI hyphen agent app. No resources found in the SBI agent app namespaces. No resources No resources found in the SBI agent app. For example, I want to see a particular default. How many pods are there in the default? Default, right? Yeah, no resources found in the default namespace also. So you can check the a particular, right? Cube system. Cube system is one of the namespace. What are the parts are there in this namespace? HCD, kube proxy, and scheduler, and API server and control manager. Right, guys? So these are the 5 minutes 22 seconds ago, 3 minutes. So 3 minutes, 55 seconds, 23 hours ago, 23 hours ago. So this is 3 minutes, right? These pods are so how many restarts are there? The age of the pods, restarts, status, and ready. Okay. So this is nothing but a namespace. Within the namespace, there are the pods available. There are the pods available. Guys, understood? Yeah. So creating the namespaces we created the namespaces. How you can create the namespaces? So this is the create a namespace. We will run our pod. We'll run our pod using the custom namespaces. How to get pods belongs to the namespace. Yes, this is the command to get the namespaces. So we will run our pod using the custom namespace. How to get pods belongs to a namespace. kubectl get pods hyphen n namespace. Get the pods of all namespaces. kubectl get pods hyphen all namespaces. No, I don't want to all. I want a particular purpose. We need to use hyphen n. Okay. So namespace creation. So yeah, creating the namespaces. kubectl get namespaces. kubectl get pods hyphen n cube system. kubectl get namespaces. kubectl get namespace test app created. kubectl get namespaces. kubectl get pods hyphen text app. So if you delete a namespace, all the object resources components also deleted. Means pods everything. So if you delete the namespace, okay. Yeah. So what is a orchestration, guys? So what is a containerization? What is orchestration? What is a Kubernetes? Kubernetes advantages, Kubernetes versus Docker Swarm versus Kubernetes, Docker architecture, multi-node cluster setup, namespaces. Now as of now, you know these, right, guys? As of now, you know what is a architecture, what is a multi-node cluster setup, what is a namespace. Namespace is nothing but a within the namespace. So within the namespace, it is a group put together. All the Kubernetes components will be available. So within the namespace, you can get the pods. You can get the pods. So what is a pod? What is a pod? Pod is a smallest building block what we can execute inside the Kubernetes cluster. Inside the Kubernetes cluster, a pod is a smallest building block what we can execute inside the cluster. Pod will execute in a node. One node can execute multiple pods. A pod can have one container, more than one container. A pod can have one container or more than one containers. A pod can have one container. A pod can have only one container or a more than one containers. So mostly a pod contains only one container, guys. One node can execute multiple pods. So one node can execute multiple pods. Pod can have one container or more than one container. Pod represents a running process. Pod represents the running processes. So containers inside the pod will share a unique network IP, storage, and other specifications. Guys, now you understood? So why we are taking the pod, right? So pod, a container inside the container inside the pod will share the unique network, storage, and other applications. The pod will share the network, pod will share the IP addresses, pod will share the specifications. To run our Docker image, we need to create a pod, then Kubernetes will execute that pod. To run our Docker image, we want to run our Docker image. So we need to create a pod. So if you want to run our Docker image, we want to run our Docker image as a container, we need to create a pod, then Kubernetes will execute that pod. If we have a pod, then we can send request to the Kubernetes to schedule that pod execution. So if you have a pod, right, then we can send request to the Kubernetes scheduler that the pod execution. So how to run our application in Kubernetes? How to run our application in Kubernetes? Yeah, this is the big question, guys. How to run our application, WhatsApp, Facebook, to run our Docker image. To run our Docker image, we need to create a pod, then Kubernetes will execute that pod in a node. If we have a pod, then we can send request to the Kubernetes to schedule that pod execution. So we can create pod in two ways. One is interactive mode, the other one is declarative mode. So what is that, guys? Interactive mode and declarative mode. Pod in two ways. We can create pod in two ways, interactive and declarative. So interactive is nothing but a interactive approach means using commands we can create the pod. Interactive means so we can create kubectl run hyphen name java web app hyphen image equal to techworld with hari dot java. So techworld with hari dot java or something like what is that our web our Docker Hub. So this is Hari Krishna 857. So you can use the Tomcat. So this is the kubectl run name hyphen name Java web app image equal to this. This is a interactive approach. So declarative approach means using manifest files, guys. So Kubernetes having the manifest files. Manifest files are writing. So manifest files will write through AML. We can create a pod, right? So interactive mode and declarative mode. So most of the real time we are using the declarative approach. Most of the real time we are using the declarative approach. Declarative approach means manifest files we can create the pod. The manifest files what you need API version kind metadata spec. These we need, guys. API version kind is nothing but a pod. So we need to specify the what we want to create. Metadata spec is nothing but in the specifications you need to provide the containers. So you need to provide the containers. Guys, understood? So interactive approach means using the commands. Interactive approach means using the commands. Understood? Interactive approach means using the commands. I will show you guys. Yeah. So what is your Docker Hub account? Hub.docker.com, right? So this is your account. So you want to, yeah, this is the doc Hari Krishna 7 Tomcat, right? This is the my image copy. So I'm copying the image and I want to run it in the Kubernetes cluster. So how you can run, guys? How you can run, guys? How you can run it by using the interactive mode. Interactive mode is nothing but you can create your pod by using the commands. What is the command? kubectl kubectl run hyphen name equal to hyphen name java web app. Java web app is my namespace. Java web app pod, for example. Java web app pod is my namespace, and image hyphen image equal to. So where it comes from? It comes from paste Hare Krishna dot Tomcat 9. Let's check, guys. The connection to the server was refused. Did you specify the right host or port? Yeah, shit, guys. Only again that got I. kubectl run the namespace java pod image. Yeah, pod, right? We need to start these two also worker nodes. So it will verify where the space is available to create the pod, guys. So where the space is available to create the pods, guys. So one is running, right? You can connect this one. Connect. So this is a Kubernetes master. This is a Kubernetes worker node. Yeah, I need to run another. Connect. Connect. So what is the service, guys? Starter Kubernetes kubelet, right? Sudo system ctl status kubelet. Yeah, kubelet is running, right? I need to restart it. kubectl get parts. Net 6, guys. I'm rebooting my machine. Sudo net 6. So Monday I will show you guys how to install the Kubernetes cluster in the EKS, guys. So Monday we'll install the Kubernetes EKS, and so we will work from the EKS only, guys. Okay. So what you guys can do, you guys can install the Minikube. So and I will also try to install Minikube and we'll work on the Minikube also. But we need a cluster setup, right? Worker node and master nodes. That's the reason I am setting up this, guys. Not yet restarted. kubectl get parts. No resource found in the default namespace. kubectl get parts. What this is the behavior, guys. So what is that? Kubectl get nodes, huh? The connection to the server was refused. Did you specify the right host? You specified the right host, right? kubectl sudo systemctl restart kubelet, guys. Yeah, guys, I will show you on Monday how to create the approach, declarative approach. Yeah. So declarative approach means we need to provide the app file, manifest file. So in the real world, so in the Kubernetes, we are using the manifest files, guys. What is that? Manifest files. Meaning of the API kind metadata. So what is that, guys? Meaning of API kind metadata spec. So meaning of API kind metadata. API versions represent the version of our API like V1, V2, V3. So API version represents the version of our API like V1, V2, V3, V4 and so on. Kind represents the what purpose of this manifest file. This manifest file is purpose is to creating the pod. Means kind is pod. So metadata represents the data about the data. So something like it is represents a, so we are creating the pod. So that is the metadata. A spec represents the specification, what you want to use for this manifest. You want what you want. I want to create a image. I want to use this image, create a container. Create a container. This is the spec, guys. So Java web app pod.yaml, for example. So API version v1, kind pod. We need to create the pod. So metadata, name Java web app, labels. So this is the, so this is nothing but a data about the data, guys. So this is about the data about the data. Name equal to web app. So just it's not work executing, but it's so name equal to Java web app pod. So labels, in the labels app equal to app web app spec. This is the most important, guys. So kind API spec. Spec is nothing spec is nothing but specifications. So container. So specs in the contents. We are running the containers. Name equal to Java web app container. Image, where you can take the image. Image take from the Tomcat, Tech World or Harry 87 and the Tomcat 9. So ports, you want to expose any ports or container port. So container port is, this is nothing but a host port. This is nothing but a container port. So container port we need to enable 8080. This is just a simple manifest file for the Kubernetes cluster we need to create for the pod. So this is for running the, this is the interactive approach. This is the declarative approach. Nice, understood? In the declarative approach, how it's simple. So just API version, kind of metadata spec. So in the spec, we need to provide the containers. Nice, understood? So pod commands, kubectl get pods, create a pod using the manifest file, kubectl apply. So how you can create the manifest file? So up pod. So by using the interactive mode, you can run the kubectl run. So if you want to create a pod by using the manifest file, you can use the apply command. Kubectl apply -f java web pod.yaml. It will automatically create the pod by using the manifest file. Describe the pod using the below command. Kubectl describe pod Java web app. Describe means it will shows the IP address, everything, guys. It will shows everything. Check whether the pod is running. Kubectl get pods -o wide. So we can access the pod across the cluster using the pod IP. So we cannot so we cannot access the pod using the pod IP outside of the cluster. I will show you guys that one. Guys, understood? Now you can, how you can create and how you can start the pods. Now you understood, right? Pod lifecycle. So make a request to a API server. Make a request to a, how you are giving a request by using the kubectl apply. Kubectl apply, you are providing the YAML file. Make a request to the API server using the manifest file to create a pod. So API server will save the pod info in the etcd. So the information, whatever the specifications, right, you do provided. So that will save in the pod info. etcd. Scheduler find the unscheduled pod info and scheduled that pod for the execution in the node. So it will verify the worker node 1 and worker node 2 where having the space to create the pod. Who is that scheduler? Find the unscheduled pod info and schedule that pod for execution in the node. Kubelet will see that pod execution schedule and it will trigger the Docker runtime. Docker runtime will run the container inside the pod. A pod is a empirical, lives for a short period of time. When pod is recreated, then the pod IP will change. It is not recommended to access the pod using the pod IP. So we'll show you guys tomorrow. So what is a Kubernetes service? So the pod, right? Now you understood how to create the pods. Inside the pods, you can create the container. Pod is a smallest building block where we can execute inside the Kubernetes cluster. Pod will execute inside a node. One node can execute multiple pods. Pods can have one container, more than one container. Pod represents running process. Prod represent a running process. Container inside the pod will share a unique network IP, storage, and other specifications. To run our Docker image, we need to create the pod. We need to create the pod, then Kubernetes will execute that pod. If you have a pod, then we can send the request to the Kubernetes to schedule the pod for the execution. Pod for that execution. Yes, understood? So this is nothing but a pod. This is nothing but a pod. How you can create a pod, guys? Just a simple API version kind of metadata spec. This is the a simple a manifest file, guys. A simple manifest file. Okay. So we'll show it on Monday classes. Okay. So thank you, guys. We'll continue from tomorrow, guys. Every day, please join at 7 o'clock because of so we need to at least we need to learn something like 45 days to 50 45 minutes to 50 minutes, guys. Otherwise, so every day I'm asking the question, so it will be losing the 15 minutes to 20 minutes, right, guys? From Monday onwards, you guys can start at least 7 o'clock, guys, please. Okay.
ఒకటి ఎన్నింటికి ఉంటారు భూమి దగ్గర?
Okay, guys, thank you.